Hello everybody, we are the team conformed by Oliver, Martin, Luis Enrique, and Juan. And in this video, we are going to explain what we did in our Equilibrium Thermodynamics page.
Here we have the interface of our website. It looks very nice. In the first page, we find a tab that explains what is equilibrium thermodynamics. And there is an explanatory video to help the people to understand the definitions in the topic. Here in the left section, we can find some tabs. The first tab will guide us to the different topics we will talk about in this page. Also, if you want to go directly to the topics, you can choose for whatever you want. In the third tab, we have a page in which the people who browse the website will know more about us. Here is a little picture of our team in characters and a little description of who we are and why are we doing this project. In the fourth tab, we have a contact, so people who has a question can ask us and we will answer. Here is a physical address in which we are located, and for the last tab, there are the references we are using to make this page. For this topic, we will have the definitions of what is equilibrium and what is steady state. Here, we put the difference between each of them, and also we put a video to help the people to understand the concept more clearly than that of our explanations. Here in this page we have the definition of fugacity. Fugacity is a very complex term we learned in class, so we try to describe it the more simply we can, but it's difficult for all people to understand. We also include the equations from where fugacity is developed, charts, and a special comic right in this button where you can learn more about fugacity in a very hilarious way. Also, we include a little infographic in which we summarize the information because there are no big explanatory videos easy to understand where we can take off. Also, we include 3 examples of where to calculate and when to calculate fugacity in these buttons. We can see they open in a different tab, each of them.
In this section of the website, we are going to learn about the Gibbs free energy. In the first section of the page, we can learn about the biography of Joseph Willard Gibbs. Then we will understand what the Gibbs free energy is, and when conditions are established to determine the equation, which is below. Finally, there is a video summary explaining everything about laws of thermodynamics and of course the Gibbs free energy. Now, for this section, we will discuss about how the chemical potential is used since the creation of the gunpowder, its definition, which is the energy that is stored in the chemical bonds of a substance, and some examples in real life where chemical potential is used, such as in the gasoline and in the dynamite. Finally, there will be a video explaining in details what chemical potential is and how it is transformed. For our the phase separation tab, we are going to explain how it has been changing the process over the years. Next, we will discuss about all the properties that can affect the mixture, such as the temperature or the partial pressures. Also, the importance of analyzing in which phases are going to be the mixture for a phase separation and different strategies to separate it. Finally, in the bottom, there is a button that will take you to the PXY and TXY diagrams. Important to understand so you can know at at which temperature and pressure you will need to be your system so you can separate in a more efficient way. It will be explained every component of both diagrams, and a video to have a better understanding of the subject.
In this tab, we analyze what is the phase equilibrium and how it's developed. First, we start with the Gibbs phase rule to know how the number of variables you can change without disturbing the equilibrium. Then we also include some diagrams and some examples of how the boundaries between liquid vapor and solid liquid boundary works. And for last, we include some examples of how to calculate the equilibrium between liquids and vapor and solid and liquid, and also the triple point, which is where the three phases of a substance can be in equilibrium. And for last but not least, we have the Applications tab, where you can see a real-life application of the topics we have been discussing in all of our website, so you can get a more peculiar way to see how this equilibrium thermodynamic works in real-life applications, and also a beautiful image at the end to get a refreshing feeling for all the people who enter in our website.
On this section of the website, we explain the definition of spontaneity in thermodynamics, which refers as a natural process occurring without apparent external cause. Some examples are shown to understand different situations where spontaneity is presented in daily life. At the bottom of the tab, a video will explain in a more explicit way a spontaneous process. On this tab, we will explain one of the most important topics of the course, which is mixtures. First of all, a video will help us to understand the basic information about the differences between mixtures and pure substances. Then, a partial molar property concept will be shown, which refers to the contribution of each species in the mixture and the analysis of the mixture as one complete system. Another tab will be shown in order to explain how to calculate fugacity in liquids. Some new concepts will be demonstrated, such as activity coefficient, which tell us how active the liquid is relative to our choice of reference state. To know which reference state must be used, then you need to analyze the Lewis-Randall and Henry's law characteristics to determine which one you need to apply. In conclusion, by doing this project, we understood how important it is to share the knowledge acquired in the Equilibrium Thermodynamics course, since it is a subject that has several abstract concepts, of which you need as many tools as possible to understand all the situations in which those concepts are required. Also, it helps us to consolidate the concepts seen in class by trying to explain them in a more didactic way.